Suppose you want your page to have one of those cool collapsing, expanding lists. We now know enough to make it happen, and so we'll tell the story. So we'll start our page with an H1 tag to label the page, then follow with a set of paragraphs which will serve as headers for each of the lists. So H1, web-related curricula, then HTML classes, CSS classes, JavaScript classes, PHP classes. Now we'll just focus on the JavaScript curriculum. Once we have that, the rest will be similar, so easy. Since we want to show a list of courses, we'll need a list element, maybe like this. So after the JavaScript classes paragraph, an unordered list. And I'll say type equals disk, but important ID equals, and I'll call it J_list. Our strategy is to add an on-click event handler in the paragraph tag. And in that event handler, we'll create a new list item element. Then create a text node with the content of the list item element. Append the text node to the list item element as a child. And append the resulting list item element to the unordered list element. And voila, you've added a new list item child element to the unordered list element. Repeating the process for all three courses, we then put this code into the on-click event handler for the paragraph. So there's our H1 again, and HTML classes, CSS classes. Now the next paragraph begins with the on-click. And you'll notice we do the create li element, create text, and append it. And then append that to the ul element. And we repeat that for the J120 course and the J130 course. And then after that, we'll have the paragraph ending for JavaScript classes, and then the PHP classes. And this works like a champ, except for a couple of things. Every time you click the paragraph, you repeatedly add the same three courses. And the text of the paragraph continues to say, JavaScript classes, click for details, even though the user has already clicked. So, we need a way to tell that the list has already been expanded. And if it has, then we should contract it instead of expanding it. And while we're at it, when the list is expanded, let's change the paragraph text to say, JavaScript classes, click to hide. And then we need to find a way to close up the list. Well, we'll need a variable to keep track if the list is expanded or closed. Var j_open equals false will indicate the list is not in expanded state. But we can't put this declaration in the event handler. It will automatically be set to false every time you click on the paragraph. So we'll do like we did in the previous lesson and put this declare in a script element in the head. So script var jopen equals false. And now we can rewrite our on-click event handler so that if jopen is false, the list will be expanded, and we will then set jopen to true. And if jopen is true, the list will be closed up, and we will set jopen to false. So again, just focusing on the JavaScript courses, we now have p on-click equals, and then this big thing in quotes, if jopen equals false, and then in braces the 3 sets of 4 lines each we did to display the various courses, plus jopen equals true. And then we have an else part of the if statement, and in braces, code to close the list and jopen equals false, and then we close the start tag with JavaScript classes, click for details. Notice the line /* code to close list */. This is a comment for JavaScript programs. Start with a / and end with an */. Comments can wrap around lines. These use the same syntax as comments for style sheets. While we're at it, recall that jopen equals false can also be written not jopen. So, how do you imagine we'll close our lists? Since we expanded the list by adding elements using DOM methods, we probably perform the reverse process to close the list. Remove the list elements. And that's true. And the good news is, it's a simpler process. We just use the remove child method on the list element. So now we have the same initial statements, and in the else loop, it's document.getElementById JList remove child of J110 and J120 and J130. Now, the only remaining issue is changing the paragraph text. When the list is closed up, we want it to say JavaScript classes, click for details. But when the list is expanded, we want it to say JavaScript classes, click to hide. We change the paragraph text with these steps. Assign an ID to the header paragraph. Then access the header paragraph element. Hold equals document.getElementById using the ID we just assigned to the paragraph. And you replace the data for the first child with the desired text. That is, hold.firstChild.replaceData, parenthesis 0, 99, and then the literal that you want to have for the title. Or hold.firstChild.replaceData 0 through 99, and the literal that you want to have when you want to indicate the list should be closed. So this results in this code here. The new things are what we put in the paragraph, ID, JList head, and then the hold statements for both sides of the if. Well, that's gotten to be pretty complicated in the body. Tough to maintain or fix if an error is found. Fortunately, JavaScript has the ability to define functions, callable routines. And this is useful for having common code called from multiple points in the page, or simplifying coding, or easing maintenance, or making pages more dynamic. A function is defined by a function header and a function body. A function header is the word function, followed by the name of the function, followed by a pair of parentheses containing an optional list of parameters separated by commas. A function body is the lines of code that implement the function enclosed in braces. In the examples in this video, we will not need to pass parameters. How to pass and handle parameters and functions will be discussed later. A function definition is usually placed in a script element. For example, we might expand our existing script element by adding two functions like this. Here you see we took the first part of the onClick event handler for expanding the list and put it in a function called open JavaScript. And then the else part of that onClick event handler, we made a separate function called close JavaScript. And we put them in the script element. So you see the function headers and the function bodies. Then in our body element, we invoke the function by naming it and passing arguments. Well, in this case, there are no arguments to pass. Arguments will be discussed later. So now we're taking a look at our paragraph, and we have the ID, JList head, and onClick if not jopen, open JavaScript, parent, that's all. Else close JavaScript, parent, that's all. And the rest of the paragraph. Of course, all we've done is transfer complexity from the body element into the script element in the head. But we can take this a step further by removing scripts to an external file. And then this file can be easily edited on its own and can be used by multiple pages. So let's take a new look at the script element. The syntax as before, a start tag, script, possibly some attributes, and script content, and end script. There's really only one useful attribute we care about right now, and that's source, src. And there you point to the name of the external file that has your script. There's other attributes available, but not discussed here. Note, if you use the source attribute, there can be no content because the source attribute is pointing to the external file that has the content. So here we are in our HTML file. Let's highlight the two function definitions and use Control-X to cut the code from our page into the clipboard. Then bring up Notepad, then use Control-V to paste the clipboard into the empty area. Then bring up the Save As dialog to save this file in the same directory as our HTML file, giving it a name that ends in .js for JavaScript. Let's say js_openclose.js. Then go back to our HTML page and add a new script element. Where it's script source equals js_openclose.js. And script, notice no content. And now it will work just fine, and you can use that source or that script statement in any HTML page that it's relevant for. At this point, you can use our trick of changing the script file for use with the other courses and then doing a save as HTML openclose.js and then CSS openclose.js and PHP openclose.js respectively, and then referring to these scripts from your original HTML page. A few more words about remote scripts and JavaScript itself. The name of a remote script written in JavaScript should end in .js, although the browser will open any file name and treat it as a script since it comes in as the value of a source attribute in a script element. As mentioned, JavaScript comments are of the form /* to start and */ to end. Blank lines are allowed anywhere in JavaScript. Indentation is not required, but we recommend it to help you visually understand the structure of your code. Recall that statements in script elements are run at the time the page is being loaded, but functions are not run until they're explicitly invoked, usually from event handlers. So variables defined and initialized in script elements are ready to go when event handlers or functions reference them, and they're known globally, that is, throughout the whole HTML document. My personal preference is to define global variables in one script element, then reference external JavaScript files in separate script elements. Scripts may not contain HTML elements, although they can generate HTML elements using DOM methods, as we've seen. Note that often users will disable the running of scripts. There may be a variety of reasons for this, but you need to know how to work with this environment. The simplest way is to include a noscript element. The syntax is a start tag, noscript, and then your content and an end tag. The global attributes are available, but not much interest here. The allowed content of a noscript element depends on where it is coded, in the head or in the body. If the noscript element is in the head, it must only contain link, style, and meta elements. If the noscript element is in the body, it must contain valid HTML code, although such code may not contain noscript elements. That is, nesting of noscript elements is not allowed. In other words, you might have standard HTML elements that display when scripting is turned off, but are not seen when scripting is enabled. All this allows for providing alternate content, but no dynamic changing, for users who turn off the execution of scripts. Here's an example coded in the body. Noscript. Script execution is disabled. Go to a href equals showResult.html, show result, and a to view content, and noscript. A little recap of this session. we've demonstrated techniques to dynamically add and delete elements to your HTML page. We introduced the concepts and syntax of JavaScript functions. We demonstrated how to use remote JavaScript code stored in external files. And we introduced the noscript element. Coming up, in the next video, we show how to generate a page in a separate window. See you there.